So we have covered the biggest parts of what we have to cover for this class. The biggest things we have to look at are linear equations, exponential equations, and quadratic equations. We have fully covered those. We have a few other little things like solving equations that we did at the very beginning. We've got a little bit of geometry that we have to do and some statistics. Those are really small units that we'll do after we finish these. So we're getting pretty close to the end. But Unit 9 is just going to be really not new information, but comparing different types of functions that we have already learned about. Okay? So, for Unit 9, Section 1 hopefully should be something we can get through pretty quickly. It is mostly on being able to identify what is linear, what is exponential, and what is quadratic. Okay, so by looking at our equations, being able to tell which one would look like a line if we graphed it, which one is a parabola, which one is an exponential. So linear problems from a graph are going to be a straight line, right? Those should be the most easy to identify from a graph. Exponential had this curved shape here. You can think about things growing exponentially. They start off slow, but then they take off. So that gives you this curved shape here. We didn't look at graphs as much with exponentials as we did use those in like context to solve problems. But this is what the graph would look like. And then quadratics are the parabolas that we have been looking at a lot lately. Okay? So these are the main three types of graphs we have to focus on in Math 1, and we need to be able to identify them. So from a graph, if you see these shapes, you should be able to tell linear, exponential, or quadratic. From an equation, we have linear equations. The way that we can know that something is a linear equation is it has one x and one y most of the time. There are two exceptions. There are two types of lines that don't have an x and a y. Can somebody tell me what those are? Okay, so let's put over here except horizontal lines. Horizontal lines, what's their equations? Y equals a number. So it will not have an x, it only has y equal to a number. And then vertical is going to be x equals a number. So some examples of linear equations. The ones we think of most often are like y equals mx plus b, right? Y equals mx plus b gives us the equation of the line. M is our slope, b is our y-intercept. So like y equals 2x or y equals 7 minus 4x, those should be easily identifiable as lines. They also might be in what we call standard form, which we didn't spend any time talking about. But if there's only one x and one y, then that is going to be linear there, because you could solve this for y to get it y equals mx plus b. Okay, so these would be examples of linear equations. Exponential equations, how can I tell something is exponential? Okay, the variable is in the exponent. Okay, so for example, it could be something very simple like 3 to the x power, or something more complicated, 4,000 times 1.03 to the x power, right? But still, I can see that variable is in the exponent. Okay? how can we tell something is quadratic by looking at its equation? What do you think, Evan? There is an x to the second power. Okay. So some examples here. Y equals 8 minus x squared. Y equals 3x squared minus 4x plus 2. This one right here, does this one have an x squared in its equation? It doesn't, but you're squaring this on the outside, right? So if you squared it, you would get an x squared, right? So it still involves squaring something that has an x in it. So that's going to also be a quadratic. Okay, questions? Okay. These are the most difficult to figure out. Okay? All right, so if we're looking at a table, okay, our linear equations are going to have a constant rate of change. Okay, your rate of change is also known as your slope. It is your change in y over your change in x. Right? So, for example, on this table, this goes down by 3. This goes up by 1. Down 3. Up by 1. Down 3. Up by 1. Same thing's happening each time, right? Every time my x increases 1, my y value is decreasing 3. So I'm going down by the same amount each time. Okay? Questions on that? All right, so you should see a constant rate of change. Do be careful because, like, for example, if I have this, does this have a constant rate of change? Okay, why not? Because it's going up by 3 each time. But I'm not going up by the same amount on the top each time. So this would be 3 over 3. This one would be 3 over 4. This one would be 3 over 3. So you wouldn't have a constant rate of change. So that one actually would not be any of those. But you do have to pay attention to what's happening with your x values also. All right, if we have something that is exponential, we will either have an increasing or decreasing rate of change. And a lot of times with exponentials, not always if you have a really low rate that you're growing at, but if you have a higher rate, it's not only is it going to increase, it's going to increase fast, right? So like if we look at this one, I go from 2 to 6, which is up 4. The next is up 12. And then the next one is up a lot more than that. 36. That looks right. Okay, and then the x's were just increasing by 1. So this would be the case where we're growing a lot, more and more and more. It can be a little tricky to tell the difference between a quadratic and an exponential just looking at the table. Because part of an exponential is also going to have an increasing rate of change. But with a quadratic, what happens is you go up and then you go back down, right? Or you go down and then you go back up with a quadratic. So a quadratic's rate of change is going to be, it increases and then decreases. And then it says or vice versa. What's vice versa mean? Right, we could switch those other way around. So what we're going to see with the numbers here is that you should go up and then down, or you might go down and then up. So like for this one, our x's are just increasing by 1 each time. I would go down 3, down 1, but then I go up 1, up 3, up 5. Let me show you one more thing about quadratics. I just learned this last, the last math training that we went to. I had never seen this, but it opened my eyes. So, all right, so this is your rate of change. Or your slope, and we can see it's not constant. It's not staying the same. Up here with the linear, it was constant, right? -3, -3, -3. If something is quadratic, the rate of change of the rate of change, the rate of change of the rate of change. If you do this a second time, so if you look at the difference here, and then you do it a second time, from -3 to -1, how much do I go up? 2. Okay, from -1 to 1, 2, 2, 2. So if something is quadratic, its rate of change is not going to be constant, but its second rate of change, the rate of the rate, will be constant. So that is one way we can tell the difference between an exponential and a quadratic. Most of the time you can tell the difference between exponential and quadratic because a quadratic will go up and then back down. But, for example, if they had left off these two numbers right here on our table, it would not have been super obvious that this went down and then back up, right? So if they only give you a piece where it's increasing, it might be a little harder. I don't think they're going to do that a lot, but they could. So this is another way you can tell. If you look at the rate of change of the rate of change for a quadratic, it will be, your second rate of change will be constant. So I thought that was kind of cool because I did not know it. Even though I should have, it makes total sense with derivatives and calculus. But I had never seen that, so that was interesting to me. Let's look at a few tables, and then we are actually, I think this is actually from your worksheet, so let me give you a worksheet first. Pass those back. I'm pretty sure. Hold on, I think I've got. I need to get my other notebook back. I don't know. I passed out everything I had. Does anybody have an extra? Oh, I don't know. Yeah, everybody check and see that extra. Alright, maybe I can find the key in a second. Okay, let's just look at these four, and then I'm going to go look for the key for this that hopefully I've got somewhere. Or may just have to wing it. Let's see, oh, we still didn't find one for 8. Probably somewhere, but all right. Okay. Okay. So if we're looking at these, most of these tables that you're going to see, your X's are all increasing by 1, so you don't have to pay a lot of attention to that. But here, I go up by 1/2. Go up by 1, go up by 2, go up by 4, go up by 8, go up by 16, right? If I look at that difference that's happening each time. So it would appear, because those numbers are increasing, that this would be exponential. So exponential. If you want to be double sure it's not quadratic, you could look at that second difference. So it goes up by 0.5, and then up by 1, and then up by 2, and then up by, what do you see is happening here? It's the same, right? It's not constant. It's the same. That's another indication that it is exponential there. Probably. Yeah, it's just going to keep doing the same thing over and over again. It's kind of cool, actually. I think it does that without, does it do that with all exponentials? Let's look at that last one. Probably so. Let's see. Our exponential example, yeah, because from 4 to 12, that'll be, well, no, that's different. It's times 3 instead of, it'll be, because you'll have 8 and, so it's not going to be necessarily always the exact same, but you'll see, the main thing is you'll see it's not, that second difference is not constant. If it's quadratic, it'll be constant. Now, if we look at this one, and, you know, these tables are kind of long. If those negative numbers bother you, just start over here. This is going to be up 5, up 5, up 5. Yeah, I think so too, right? And so even with these negative numbers, it was still going up by 5. So that's linear. All right. This one is 10, and then up by 8, up by, oh wait, it's minus. Get rid of those positives. Minus 10, minus 8, minus 6, minus 4, minus 2. Nothing, right? What does that double zero make you think may have happened here? I don't think, so linear but if we're only looking at linear, exponential, and quadratic, none of those just stop. What do you think, Aiden? Right, it hit its minimum somewhere here between 0 and it started back up, right? So it was at 0 and then it started going back up to 0. It's not like super obvious that it did that, but that's probably what's happening. You can always check that second difference. So this is going up 2, up 2, up 2, and that's constant. It's always the same number, right? So this is quadratic for sure. What do you guys think about number 10? Linear. You're going down by 2 each time, so that's going to be linear. Okay, I think probably the tables will be the more difficult of these for you. You should be able to probably do the other ones fairly easily, I believe. So go through these, work on those problems. Aiden, I'm going to print you one.